We're going to be working on pages 386 and 392 in the workbook. Number 8 on page 386 says, last week it rained G inches. This week the amount of rain decreased by 5%. Which expressions represent the amount of rain that fell this week? Select all that apply. So we know that the amount of rain decreased by 5%. So we need to change 5% into a decimal in order to use it in our equation. So 5% as a decimal is 0.05. And we know that it rained G inches. In order for it to decrease by 5%, we would need to do 0.05 times G, or 0.05 G. So we know that we're going to have that in our equation somewhere. Now we know that it decreased, so we have to subtract that amount, and it's going to decrease from the amount that it rained last week, which was G inches. So our equation is going to have something like G, or 1G, minus 0.05 G. Now I know that 1 minus 0.05 is going to be equal to 0.95. So in my equation, I'm going to have something like this first part, G minus 0.05 G, or I'm going to have something like 0.95 G. So I want to keep an eye out for those in the equations here. Now let's take a look at the equations and we can see if they match our pattern that we came up with. The first one, G minus 0.05. Now this starts off good, but if you notice here, there's nothing on the end of this 0.05. So what this is saying is that it's not decreasing by 5%, it's just decreasing by 0.05 or by 5/100ths, no matter what. And that doesn't match our situation. Remember, it needs to decrease by 5% of whatever it rained last week. So that one is not going to work for us. So I'm not going to select it. B says G minus 0.05 G. Well, this is exactly what we came up with here in our original equation. So that one matches. C says 0.95 G. Well, that's this part that we came up with when we subtracted the 1 minus the 0.05. We got 0.95 G. So that one works as well. This one means that it's 95% left, right? 0.95 is 95%. So that's why that one works. And let's see, D is just 0.05 G. Well, that's how much it's decreasing, but that doesn't, that's not all that we need for our expression. And then E is 1 minus 0.05 times G. Now, this one, since we have parentheses here, we can do the operation inside of the parentheses. I know that 1 minus 0.05 is 0.95. So this one is going to work out to 0.95 G, which is the same as C, and it's also the same that we came up with when we were writing the original expression. So that one will work as well. Let's move on to problems 9 and 10. It says, determine whether each equation represents a proportional relationship. Explain your thinking. Now, way back when, we talked about what it means for an equation to be proportional. And we said that a proportional equation looks like this. Y equals K times X, where Y and X are variables, and K, if you remember, is the constant of proportionality. So this part here, this K, is our constant of proportionality. We also call it at one point the scale factor. So when I'm looking at these equations, in order for them to be proportional, they should match this same format, y equals k times x, or some variable equals a number times another variable. Now let's look at the first one. Volume measured in cup C and the same volume measured in ounces Z. And the equation that they give us is C equals 1/8 Z. Now this one looks exactly like our proportional equation. And it matches the same format. So this equation matches the format y equals k times x. So it must be proportional. If we look at number 10, it says the length L and width W for a rectangle whose area is 60 square units. And the equation is L equals 60 divided by W. So in this case, since the format of the equation does not match a proportional equation's format, it needs to be y equals k times x. This one would be y equals k divided by x. So since it doesn't match the format, this one is not going to be proportional. So this equation is not proportional because it doesn't match the format y equals k times x. Let's go on to number 11. It says Tiam bought a train ticket online. The original price of the train ticket was $83. They used a coupon to receive a 20% discount, and a sales tax of 9% was applied after the discount. How much did Tiam end up paying? Well, this is a two-part problem. We have our discount here, and then we have a sales tax. Remember that a discount means that the price is going to go down. So here's our discount of 20%. And the sales tax means that the price is going to increase. So we have a percent decrease and then a percent increase. So let's go ahead and dive in. Now I know that 20% as a decimal is 0.2. And what I need to do is I need to take this away from the original amount that we're going to pay. And so we're originally going to pay 100% of the price, but we're going to take away 20%. And so that will mean we have to pay 80%. Now 80% as a decimal is 0.8. So when we do the discount, we're going to end up paying 80% of the original price, which was $83. So we could take our $83 and multiply that times 0.8, and that will tell us how much money we're actually going to pay after we do the discount. So 83 times 0.8 is equal to 66.4, or $66.40. So this is after the discount. We're going to pay $66. Now we still have to do the sales tax. Now the sales tax is 9%, but we're going to start with 100%. That's the original amount that we're going to pay, plus 9%, and that's equal to 109%. We could take our 109% and turn it into a decimal. 109% as a decimal is going to be 1.09. Now we can use this in order to find the amount that we're going to pay after the tax. So let's take our $66.46 and times it by 1.09. And when we do that, we're going to get 72.376. Now, we're going to need to do some rounding because what this is saying is it's $72.37 and then 6/10 of a cent. And we can't do that. So we're going to need to round this 7. Now, since the digit that comes after the 7, this 6 here, is 5 or higher, then we need to round the 7 up. So we're going to have $72, and instead of 37 cents, we're going to have 38 cents since we rounded it up. So this is our final price after we do the discount and after we do the sales tax. And we can see here it matches with letter option C, $72.38. So we can be pretty sure that we got the right answer. All right, let's move on to page 392. Okay, here we are at page 392. It says, use the number lines to determine the value of each expression. The first one is 4 minus 6. So we'll start at 4 here. And one thing to note about this number line is that not every number is marked on this number line. You can see these hash marks are where the 3 and where the 5 is. So we need to be mindful of that when we're doing our jumps. So we have minus 6, so we're going to move towards the negative side. And we'll move 1, 2, 3, 4, 5, 6 spaces. I'll make sure to put an arrow on the end of my jumps here. And I can label, this was minus 6. And 4 minus 6, we ended up at negative 2. So 4 minus 6 is equal to negative 2. Let's try the next one. Negative 3 plus negative 2. We'll start at negative 3. It's not marked on our number line, but we know it's here. And then we have plus negative 2. So this means that we're adding 2 negatives or 2 anchors. So we're going to be moving down on the number line since we're adding in anchors. So we'll move 1, 2 steps for those 2 anchors. Draw an arrow at the end of our number line. And this was adding a negative 2, oops, not equals, adding a negative 2. And we ended up at negative 5, although it's not marked on the number line either. For the last one, we have negative 8 minus negative 3. So we'll start at negative 8 on our number line. And we have minus negative 3. So this means we're removing 3 negatives, or we're removing 3 anchors. So that means we're going to move up. So we'll move up 3 spaces. 1, 2, 3 spaces on the number line. And we end up, sorry, this was removing, or minus negative 3, and we end up at negative 5. Let's go on to problem number 4. It says complete the tables and answer the follow-up questions. So for this we have a series of expressions and we want to give the value to it. So the first one is 2 plus negative 3. So we're going to start at 2. We're going to move down 3 spaces. So we'll end up at negative 1. For the next one, negative 8 plus 4. Well, if we look back at our number line, we start at negative 8. We move up 4 spaces. 1, 2, 3, 4. We'll end at negative 4. The next one's done for us. And then finally we have negative 3.6 plus negative 2.6. Now if we think about it, we're going to start at negative 3.6. It's somewhere over here on our number line. And we're going to move down 2.6 places because we're adding in anchors. So we're going to move down this way. Our answer will be even more negative. And the trick for this one is that we can start by adding together these two things because we're kind of getting more into the negatives. So 3.6 plus 2.6, that's equal to 6.2. And since these are both negative, we're going to be in the negative zone. So we'll have negative 6.2 will be our final answer. Let's keep going. We have negative 7 plus negative 2. So if we think about, we start at -7 on our number line, and then we're going to move down because we're adding in anchors. We'll move down 2 spaces, and we'll be at -9. And for this last problem, it's -2.6 plus -3.6. Believe it or not, this is exactly the same problem that we just did. It's just the order of the numbers is switched around. But the result is still going to be the same. It's still going to be -6.2. Let's see. Use your work from previous tables to describe any patterns that you notice. Well, one of the patterns that we could say is that it doesn't matter which order you add numbers in, the result is the same. Is one thing that we can see from this table, since if we look at both tables, all of the numbers are match up. So it doesn't matter which order we add them in, even if we have some negatives. Let's go on to the next table, and here we're subtracting. So we have -6 minus -3, so we'll start at -6, and then we're removing anchors, so we're going to move up. So 3 spaces up from -6 would be -3. And in the next one we have -1.5 minus -4.7. So another way to think about this is that we start at -1.5 and we're going to move up 4.7 spaces. And we could even switch this problem around to think of it like 4.7 minus 1.5. And when we do that, it's easy to see that the answer is going to be 3.2. Now let's take a look at the problems in the next table. If you notice, they use the same numbers, okay, but their order is switched around. But this time, they're subtraction problems instead of addition problems. So let's see what happens. 2 minus 3, so we start at 2, we move down 3 spaces, and we should end up at -1. Notice how we didn't get the same answer this time as we got on the left table. Let's go to the next one, -9 minus 5. So we'll start at -9, we'll move down 5 spaces, and we'll end up at -14. Once again, we did not get the same answer. And in the last one, we have -4.7 minus -1.5. So we'll start at -4.7, we'll move up 1.5 spaces, and we'll end up at -3.2. -3.2. Now, the pattern that you should see is that the values in the table on the right are the same as the values in the table on the left, but they're negative now. They're negative. So what this means is that when you're subtracting, we cannot change the order of the numbers. We won't get the same result. And that brings us to the end of the homework help video for this week. Be sure to look for the video that we'll post for next week's homework.